last day of the Chemistry Senior Experience Seminar Series. We are joined by James today. You can clap if you want. I'm excited. We are all seminared out for the term, but not until the end of today, of course. So, Stefan Debbert is going to be introducing our speaker.
I'm out of breath because I just ran here from my office, so I apologize if I sound even more hoarse. Again, it is my distinct pleasure to introduce James Kim for our senior sequence today. I've known James for longer than I've known most of you in this room. So I think he was assigned my advisee very early on, and sort of had, we talk about this kind of science generally, and then he left for military service in his native South Korea. And then he came back, and when he came back, he really knew that chemistry was the path he wanted to take. And so I said, that's going to be a hard road. You got a lot of chemistry to fit in this year, and by God, he did it. And so it's been really exciting to watch him really run the gauntlet and keep his energy up and his optimism up. And it seems like the more he's learned about chemistry, the more he's sort of taken to it. So it's been exciting. James and I have been working on this for a little while now. So again, it starts with a question. How do we test this stuff, right? And those small questions lead to bigger questions, like how do these drugs work? What are people that design testing looking for? What are some of the practical aspects of trying to test this stuff? And so James has done quite a bit of reading pretty broadly. And so I'm excited to hear about this work. So I'll turn it over to him.
Is it okay? Sounds good. So, hello and welcome everybody for my senior experience talk. Today I'll be talking about the application of detection method of gamma-hydroxy-butyrate to prevent the crime. So, did anyone watch these kind of TV shows or films? Sounds good? Because I was really a big fan of Breaking Bad during my entire high school year, and I found the drug topic as really interesting topic to watch. So illicit drug is a relevant topic in many TV shows and movies, or even easily found in the news as well. So I thought it would be very interesting to get to know some of illicit drug, like how they act like and how to prevent it. So let's dive deep in together. Nowadays, we often see news pertaining to drug more and more. In the figure, it shows a national drug-involved overdose death, and trend clearly shows that increasing in overdose death as the time goes on. In 2020, overdose death increased almost 80% comparing to the 2015s. So overall, drug issue is getting more serious, and we definitely need to pay more attention to it. Opioid crisis was serious in past years in both America and South Korea. And I was watching one documentary about opioid crisis, and in many cases, getting opioid prescribed from either doctor or the hospital was not a challenge. And that led a lot of people died from misusing prescribed opioid. And moreover, I was really shocked to see even high school students were involved into this crisis. So I think opioid crisis itself is a great example why we need to pay more attention to the illicit drugs and prevent misusage and overdosing it from it. So yeah, misusage and overdose of drug is increasing dynamically in all over the world. So today, content that I'll be talking about today, this presentation will aim one specific illicit drug, which is GHB. So first, I'll start with what is GHB. Second, what makes GHB dangerous, harmful, and potentially life-threatening. Lastly, colorimetric sensor as our detection method for GHB specific. So what is GHB? GHB is gamma-hydroxy-butyrate, but GHB does have a lot of street name, such as liquid X, liquid ecstasy, G-juice, so on and so forth. GHB is often used in the drug-facilitated sexual crime. It is a date rape drug that assailant slip into victim's drink, and victim consumes it without noticing it. So simply, GHB is a notorious date rape drug. Chemical formula of GHB looks like these. Comparing to another designer drug called LSD, GHB does have fairly easier structure, which implies that it is easy to build, and therefore GHB is fairly cheap and more abundant than any other like designer drugs. What makes GHB dangerous? And first, and the biggest reason why GHB itself is dangerous is because that dosing GHB often happens unintentionally. Assailant slip GHB in victim's drink, and victim consumes it without noticing. So I would say dosing GHB is usually against victim's will. Another aspect is that GHB is odorless and it has a transparent color. So telling whether GHB is in the drink or not is a quite a challenge. And plus, if there is a more additive in the drink, it will be even harder to tell the presence of GHB. So last important aspect makes GHB dangerous comes from a severe adverse effects, and GHB has side effects including loss of consciousness, visual hallucination, headache, and amnesia. So often GHB lead many of victims to blackout and loss of their memory. Since dosing GHB often happens with consuming alcohol, like for example, GHB is usually like widely found in the party, club. So people came up with the question that will alcohol impact the effect of the GHB? And they tested. So figure A shows concentration of GHB over the time dependence, where figure B depicts a concentration of ethanol, alcohol, by the time dependence. And square filled square squared tells a dose of GHB and the alcohol together, where the empty circle depicts a dose of GHB or alcohol only. So first, dosing two substances together did not really affect the effect time for both of them, because both end at the same point. And second, it seems there's a slight increment in concentration of GHB in earlier stage. But overall, consuming alcohol together did not really play a significant role in the GHB concentration. But however, researchers could figure out that adverse effect for patients who consume GHB and the alcohol together had stronger and more like frequent adverse effect. And next data from another research shows how easy to overdose GHB. Shown table is list of adverse effect depending on the amount dosed. So 20 to 30 milligram per kilogram will cause drowsiness, sleep, where 50 milligram may cause coma. Over 50 milligram will cause onset of coma. And another data is a usual dose amount for entertaining purpose, which I tried to convert into the milligram per kilogram scale, which I ended up with 17 milligram to 83 milligram. So surprisingly, it's a quite broad range as an entertaining purpose, but overall, like it could seriously drive someone into onset coma by just trying with the entertaining purpose dosing. So therefore, not therefore, because due to small difference between the targeted effect and unwanted, like the serious adverse effect, overdose of GHB can happen easily and potentially life-threatening. And this is the news pertaining to the overdose date rape drug from 1999. So 3 teenager guy invited a girl named Samantha and her friend to their party, and guys sleep GHB into their Mountain Dew, and they consumed it without noticing. And Samantha and her friend ended up having problem with breathing, and both of them were moved into the hospital, but unfortunately, Samantha died from overdosing GHB. This directly connects to the previous slide where I talked about how easy to overdose GHB and how dangerous GHB is. So, okay, we now know how dangerous GHB is. So, what now? We need a proper detection method. And there are research detecting GHB in urine using GCMS and LCMS. But we're talking about the milligram scale, which is really tiny. So mass spectrometry is a perfect that is really good with the small amount of analyte, but limits sure that the instrument is really expensive and you need to be trained to use it as well as interpreting data. But however, this forensic detection method would not be really helpful to prevent the victims from drinking GHB spike drink because they cannot really run into the lab and test their drink before drinking it. So therefore, I would propose that we do need a real-life detection method to prevent the crime. So following features are what I want from my detection method. So first, it should be rapid. Second, it should be easy to use. And third, result should be straightforward. And lastly, it shouldn't be too costly. And building sensor from nowhere is a quiet challenge. So we'll start with what is called PCDA. And PCDA is panacosadienoic acid and is a polymer, and first synthesized by Wagner at 1969. And Cherik did first application in sensor field. So let's see how it works. By electropolymerization, monolayer of PDA, polydiacetylene, is obtained, and color of monolayer change from blue to red under some stimulation, which will say interaction between the molecule. So where Cherik used incubated biomolecules for this interaction, such as influenza virus, which I found is interesting. And although this transition looks pretty simple, like just a simple color change from blue to red, but the detailed mechanistic is not really fully understood yet. Researches applying PCDA as a sensor material is still going on in various fields, both biochemistry and chemistry. And I found detecting ATP and detecting versatile gas phase organic solvents are really cool. So takeaway, PDA is widely applicable as sensing material, and we'll definitely use it to make our sensor as well. And this scheme is general mechanism, how sensor is built. So since we have just determined that our frame would be PCDA, we need an acceptor unit. By saying acceptor unit, I'm saying that something that can bind to our frame well and then only interact with our targeted analyte. So that interaction between acceptor unit and the analyte will trigger the color transition of our PCDA from blue to red. So we need to figure out the proper acceptor unit. As our analyte, what we want to detect is a GHB. And as our acceptor unit, which will interact with analyte, we have gabazine. Gabazine is a GABA antagonist, and researchers observe a strong interaction between the gabazine and the GHB. So I think this would be a really good candidate as our acceptor unit. So acceptor unit installed in PCDA. So PCDA gabazine was built, and gabazine is the chosen acceptor unit. So it's time to check out whether using PCDA gabazine is a valid approach to build a sensor. So figure A shows a interaction site 1 to 3, where figure B shows a interaction energy between two different molecules. So first column talks about the interaction between GHB and the gabazine, and the second one talks about the interaction between gabazine and the PCDA, which is our frame for the sensor. And third column talks about interaction between GHB and PCDA. And fourth one talks about the GHB and the PCDA with the gabazine installed. So first, it shows a steady, strong interaction between GHB and gabazine. And that is the reason why we picked gabazine as our acceptor unit, because it has a strong interaction with the GHB. Second, by looking at the interaction energy, installing gabazine onto our frame PCDA sounds like a reasonable approach. And these two shows interaction between GHB and PCDA, which is blue, and one with the green is PCDA with the gabazine installed. Surprisingly, there is a strong interaction between GHB and the PCDA without gabazine. So since PCDA itself interacts really well with the GHB already, so we might wonder if gabazine is not really necessary. To answer this question, they will build two test kits, one with the PCDA with the free gabazine, second, gabazine installed PCDA. So far, we have covered a general idea how sensors work in the molecular level, and we did have unanswered question as well. To answer the question, they actually needed to build the sensor and test it, and which I found really cool. They used electrospinning to fabricate the colorimetric sensor. Electrospinning technique, which I was not really familiar with, and I got a little bit of idea while I was studying this project. Electrospinning is a method to produce an ultrafine fiber by charging and ejecting a polymer melt or solution through solution under high voltage electric field. To help understanding, I have prepared videos. First video shows how polymer is being ejected under high voltages. So those are the polymer solution and being ejected under a high voltage. And second video shows how the fabricated result looks like. I found this technique is really cool that you can really fabricate into like really fine fiber with the polymer solution. So takeaway is that the electrospinning is perfect method to produce ultra fine fiber as well as it maximizes the surface area. So by electrospinning, now they have actual fabricated sensor. So they tested with 2 different kits. The first one with PCDA with the free gabazine, and the second kit is PCDA with the gabazine installed. So using water as our solvent, test was performed. From 0 to 5, concentration of GHB is increasing, where the 0 indicates GHB-free solvent. However, I think overall, like both GHB kit 1 and 2 work perfectly fine, because we do see the color transition from blue to red, but red intensity were slightly higher in kit 2, which are shown here, comparing to the GHB kit 1. And they also observed the slight color change in test kit 1, which the red intensity also supports that. So researcher thought it implies that the gabazine was covalently bonded to the PCDA, which was our frame. And in other words, in test kit 1, GHB and the gabazine were competing each other for bonding to the PCDA, where the test kit 2 is not. So more likely, GHB will strongly bond to the gabazine installed PCDA. So simply, we'll use test kit 2. So they proceeded further researches with test kit 2, gabazine installed PCDA with various drinks. Color of sensor changed red instantly with a drink containing GHB, but some unwanted color changes observed due to various additives in the drink, such as like coffee or like wine. For wine specifically, wine does have natural occurring GHB by fermentation process. However, color change were pretty distinct and pretty rapid, and people can really tell with their naked eye visually. So overall, they could build a sensor that works at least. So they successfully built the colorimetric sensor to detect GHB in the drink. So detection was rapid, so check. Sensor is easy to use, check. Results are straightforward that users can know visually, check. Costs still remain unanswered, but my initial guess is that the overall cost shouldn't be really expensive. So generally, sensor fulfilled most of our expectations, so I would say it is worth it to research more onto it. And for the summary and future work, GHB is dangerous date rape drug, life-threatening potentially, and it is also easy to overdose it. Since GHB is odorless and colorless, we need the detection method to prevent dosing it from and prevent the crime ultimately. And building sensor using PCDA gabazine was successful. It was easy to use, results are straightforward, and it was rapid as well. For future work, there are some parts that could be still improved. Increasing accuracy would be one of them, such as minimizing unwanted color change in the test kit. And another work can be application for other drugs. Of course, GHB is not the only one date rape drug exists. So there's many other drugs out there needing detection method. And my guess is that changing a scepter unit would be one of the good approach. So I wanted to thank Dr. Stefan Debert for my senior project advisor, as well as my academic advisor, Dr. Rachel Dottie, for my Chem 680 instructor and putting all these slide talks together, and for my classmates for peer reviewing presentation. My citation, and thank you.
All right, our speaker is ready to take your questions. Oh, I see Matthew.
Yeah, I'm curious about the graph you showed with the interaction energies, like between GHB and PCDA. I was wondering if you knew what methods the researchers used to obtain that data.
To be honest, they didn't really specify how they get the data from like which kind of experiment, neither in the supplementary section. So I'm not really sure.
Do you think it was physically measured? Or do you
I
think
think so.
It was
I think it was
modeled?
based on the physical chemistry based measurements.
Interesting.
Yeah.
Justin.
Yeah, I was wondering if there's any significance to the 4% GHB as like the threshold.
It was also a threshold, but that is in the usual the amount of dose that people usually dose it, like in entertaining purpose. I think they try to meet that up as well.
Jesse.
So, like, if I go to a party and I want to test the drink that I have in front of me, have they been able to design like a test kit that I can bring with me and use right there to test the drink?
Yeah, they did with the wristband type as a paper wristband, and there's a specific section for testing. So probably we can just drop a single drop onto the using straw onto the test kit, and that will tell the color difference.
Chris.
I'm curious if the research group have any plan of adding another kind of detector, like to detect MDMA, for example, using the same base.
I didn't quite get the question. Can you repeat it?
So you're using like a detector specifically for GHB, right?
Right.
So do the research group have other detector for other drugs?
No, because this research paper that I focus on is really recent one, so I didn't really see any other detection for the different drugs.
Stefan.
So if you show that plot where they kind of show the bar graph where it shows the detection limit, yeah, you can kind of see that it doesn't. Neither one of those kits, and I get that we're looking at kit 2. It doesn't look really dose dependent, right? So once you get past 0, 1 to 5, there seems to be a little difference. So can you speak to why we see that? Why doesn't it just go up like in a linear fashion?
I think the colorimetric change is only blue to red, not going darker red or depending on concentration. If it's low, it will turn into pink. It's not working like that. It's just turning red under the certain stimulation. So
Should we think about this as there's actually very little gabazine connected to the polymer, and then 1% turns out to be more than you ever would need?
Can you repeat it?
So it could be that there's very little sensor material in the paper dot, right? And so it only takes a little bit of GHB to saturate it, to capture all of the spots. Right?
That makes sense.
In which case they should be testing between 0 and 1 to see if there is a range where you see it.
Oh. Yep.
Other questions for James? If not, let's thank our speaker again. Our next speaker is going to start at 4 o'clock in about 20 minutes. So have a snack, go to the bathroom, and come back at 4 o'clock for the next talk.